Some of this stuff is from, it's a review of GCF, LCM. We have briefly talked about prime factorization, and you guys should have learned about divisibility in elementary school. So when I'm highlighting, you're highlighting. When I'm writing, you're writing. All right, so divisibility. It is a number that is divisible by another number if it can be divided evenly. Evenly means no remainders, no decimals, no fractions, nothing like that. Bless you. And these are all the rules for each one of these numbers. So 2, if it's even. 3, if it's divisible by 3. 4, the last 2 digits are a number divisible by 4. And then the example is 12. 12 is divisible by 4 because why? What 12 divided by what gives you 4? Okay, I'm gonna be honest with y'all. I stopped teaching second period because nobody wanted to try. I will do the same with you guys because I've already taught this lesson. So therefore I can just have you guys watch the video. Like, I get it, ladies and gentlemen. I get it. You had to use your brain this morning. That doesn't mean school stops. Do you understand? This is easy. This is a review. There's no reason I don't have hands up every single time I ask a question today. Honestly. Nothing we're doing today is new. So the last 2 digits in a number have to be divisible by 4, whether it's 4, 8, 16, 24, 32, whatever. The last 2 digits have to equal something that is divisible by 4. 5, probably one of the easiest ones. The last digit's either a 0 or a 5. 6, they have to be divisible by both 2 and 3. The sum of 9 has to be divisible by 9. And then 10, it has to end in a 0. So for the number 4015, we have to write if it's divisible by these numbers, yes or no, and why. Okay, so for example, is 4015 divided by, I can't even talk, divisible by 2?
No.
Jacob?
No.
Why?
Because it's not even and it's a 5.
So it isn't even. All right. All right, 3. Is 3 divisible? Ian? No. Why?
It can't be divisible by 3.
You say that again? It's not divisible by 3?
It's not divisible by 3.
Okay. All right, what about 4? Sabrina, will you turn the light on, please? Divisible by 4, yes or no? Oakley?
No, it's not because the last 2 numbers are
All right, what about 5? Oh, my Lord. What about 5? Someone other than Travis. Hold on one second. Sophia.
The answer is yes, because the last digit is a
What about 6? What about 6? What about 6? Seth? Is it divisible by 2 or by 3? Can we divide 4,015 by 2? Can we divide it by 3? Then we can't divide it by 6, right? And we can't do it because it's not divisible by 2 or 3. What about 9? What about 9? Eason?
No,
Why?
because if you divide 2015, because the 9 can't go into 15 either.
And what about 10?
No,
Why? Raise your hand. Ian?
on red, you're walking red.
All right, slide over to the next part, prime or factors, prime, and composite. Now, factors we should already kind of know. A factor is a number that can be multiplied to make a certain number. So what are the factors of 20? So what are the factors of 20? Oakley.
1 and 20.
Okay, next.
2 and 10.
Okay, what about 3?
3. 3.
Okay, what about 4?
4 times 5.
What about 5?
4 times. It would be 5 times 4.
So,
When you would stop.
okay, so that's where we're stopping because it starts repeating. All right, factors for 100. Factors for 100. Summer.
1 times 100.
Okay,
2 times, what can I say? 2 times 50.
okay.
4 times 25.
So 3 doesn't work.
I don't think
Okay. Next.
Oh, 5 times 20.
Okay.
19.
So 6, 7, 8, and 9 don't work. How do you know?
Because we have 6 times, because we can get to 1 is 6 times.
This is absolutely infuriating today. No, it has nothing to do with that. It's just the day that we're having. All right, prime numbers. So prime numbers are a number that the only thing that you can multiply is 1 and itself. So it has exactly 2 factors, 1 and itself. All right, so an example of a prime number would be 2. Why is 2 a prime number? And 2 is actually a very special prime number, but why is 2 a prime number? Totally wrote that in the wrong place, by the way. Seth. Okay, and why is 2 a special prime number?
It's the only
It is the only even prime number. All right, so then we have 3, 5, 7. What about 9? Because it's got more than 1 in itself, right? All right, so then we have 11, 13. Why not 15?
3 times 5.
All right. 17, 19. What about 21?
3 times 7.
So it's got more than 1 in itself. 23, so on, so on, so on, so on, so on, and so on. And honestly, guys, I don't know how to make this any better than what it is right now. So this is absolutely terrible. And just real quick, make sure you have an example. So like 1 times 3 is 3, 1 times 5 is 5, and that is why those are prime numbers, because you cannot multiply anything other than 1 in itself. All right, a composite number is a number with more than 2 factors. All right, so we obviously have 4, 6, 8, 10, 9. Why does 9 work? Right, so I'm going to use 9 as an example. So I have 1 times 9, 3 times 3. 12, 15. What else? 16, 18, 20. We got 14. All kinds, right? All right, so on and so forth. So all of these will have more than that 1 in itself. All right, slide down to prime factorization. All right, prime factor is the process of breaking down a number into a product of only prime numbers. So essentially, all the prime numbers that we were just talking about, we're trying to get to there. And we're not going to write those again. You can just draw an arrow up to your prime numbers, because we're not writing prime numbers again. So at 36, 36 is not a prime number. It is a what? It's a composite number. All right, so someone raise your hand and tell me 2 numbers that I can multiply together to get 36. Emma? Okay. So you're going to do 4 times 9. Are either one of those prime numbers? No, so we can keep going. All right, so for 4, we're going to do 2 times 2. What do we know about 2? It's a prime number. So we're going to circle both of those. All right. 9, we have 3 times 3. What do we know about both of those? Prime numbers. So this becomes 2 times 2 times 3 times 3, or 2 squared times 3 squared. That is essentially prime factorization. No, I have no idea when you will ever use this in real life, so please don't ask. There might be 1.5 questions on your benchmark/EOG. And I say half because, yeah. But you have to know it for that 1.5 questions. So, all right, let's do 100. Give me 2 numbers that we can multiply together to get 100. Oakley.
25.
All right, are either one of those prime numbers? 25 and 4?
No.
No. All right, 2 times 2. Are either one of those prime numbers?
Yes.
All right. And then 25, we have 5 times 5. Are either one of those prime numbers? Yes? No?
Yes.
Okay. So you do 2 times 2 times 5 times 5, or 2 squared times 5 squared. All right, you are circling 3, and you are circling 4. That's going to be part of your homework tonight. All right, slide over to greatest common factors. So, greatest common factor, or GCF, is the largest factor 2 or more numbers share. There are 2 ways to solve. You can do it with prime factorization. I'm not even going to talk about that. Or you can do it by listing the factor list if you want to. This is the way that I do it. If you like finding prime factors and you want to do it that way, you can do it that way as well. So we're going to find the GCF of 56 and 120. So what are my factors for 56? Raise your hand. Jacob. 1 times 56.
2 times 8.
Huh?
2 times
28.
Oh, yeah. No, wait. Yeah.
Baby, just give me the factors. So we have 156, 2 times 28, 3 doesn't work, 4 times 16, 14, 14. 5 doesn't work, 6 doesn't work.
7 times 8.
Okay, that's it. All right, 120. Someone raise your hand to give me the factors for 120. All right, Violet.
1 times 120.
Keep going.
2 times 60.
Okay,
3 times 40.
okay,
40 times 30.
okay. 5 goes in. How many times?
24. No. 15.
6. 6 times what? 6 times 20. 7. 7 work. Does 7 work?
No.
Does 8 work?
Yes.
8 works. Figure it out. Coming up. Do you have a pass from the nurse? Because Miss V's going to ask for it. It's alright, just go. Alright, 8 times what? Lily. Does 9 work? Y'all tell me.
No.
What about 10?
Yes.
10 times 12. Now, all of this, what is the greatest common factor between these two? So, greatest common factor. Julian. 8. All right. Questions about GCF? Again, it's a review. Yes.
Can you go back down to the highlighting tab if you have to
All right, flip your paper over. All right, LCM is your least common multiple, and this is the number that is created when you multiply certain numbers. This is also known as repeated what? Repeated addition. All right, so what are the first couple of multiples for 4? They've done the first two, so you have 4, 8. What comes next? 12, 16, 20, 24, 28. All right, what about 6? They have the first two done for you, so 6, 12, 18, 24, 30, 36, 42. All right, when you're finding least common multiple, you are looking for the smallest two numbers. Well, 2 or more numbers. When you're finding them, you're going to list the multiples of each number, find the smallest one of each list. Keep your list going until you find the number of both lists. Now, I'm going to share a secret with you today that I have not previously shared a secret with. So the first one, pretty easy. We're going to do our sideways T. We're going to do 8 and 10. What's the first 5 multiples of 8? Raise your hand. Oakley.
First 5 is 8, 16, 24, 32, and 40.
Perfect. And then we're going to do multiples of 10. So we have 10, 20, 30, 40. Why am I stopping? Summer. Okay. So this is our LCM, which is 40. Now, I want you guys to look at this hint down here. It says, if both numbers are prime or do not have any common factors, the LCM is the product of two numbers. So I want you to look at our next one. So number 2. We have 4 and we have 7. What do you know about 7? It's a prime number. All right, so I want you to multiply 4 times 7. Raise your hand, tell me what do you get when you multiply 4 times 7. Emma? 28. So now let's find our LCM. So we're going to do 4, 8, 12, 16, 20. Then for the first 5 for 7, we have 7, 14, 21, 28, 35. I totally just had a brain fart. So we do not have a common multiple yet. So now what do we have to do? So we're going to keep going. So our LCM for this one is what? 28. So we could have saved a lot of time by simply doing 4 times 7 because it had a prime number, correct? Now, why does that not work for 8 times 10? Why does that not work for 8 times 10? Jacob? Well, it's not prime numbers, but why else? Like, what happens when we multiply 8 times 10? Sophia?
When you multiply 8 times 10, you get 80.
Right.
Which is not the least common
It's not our least common
multiple.
multiple.
Sorry.
Least common multiple. So it does not work with 2 composite numbers. All right, and I promise you, if you remember that today, it's going to make your life a lot easier. All right, sliding over to problem solving with LCM GCF. These are just a little bit of hints to help you. So when you're finding GCF, it requires you to find the smallest number you're starting with. All right, you're splitting something into sections, groups, rows, and it's the greatest number that will fit into those groups, rows, or sections. So you're looking for keywords like greatest, maximum, most, that kind of thing. You're also going to be looking for keywords like none left over or nothing remaining or evenly. Those keywords. All right? So, you guys are about to do this one on your own. It says Robert has 20 tomato plants and 24 cucumber plants. He wants to plant them in rows that only have one type of plant in each row, with the same number of plants in each row. How many plants should he plant in each row, and how many rows of each type of plant will he need? So annotate, solve, stand up when you're done. Guys, this one we are finding GCF, not LCM. Y'all are killing me today. Stand up when you're done. So, what are you figuring out right now? Nope. I don't want you to tell me. I don't want you to tell me what you think you want. I want to hear. What are you realizing as a student right now as I'm walking around? Ian. Say that again. I'm not really sure what you're saying because you're kind of trailing off. Long story short, you're not just finding the GCF. If you found the GCF, you did not answer the question correctly. There's more to GCF questions and LCM questions than just finding the GCF. There's more that goes into this because there's a lot more to this problem. What, Sophia? We're not ready to answer their problem. Honestly, like, we're not even close. Have a seat if you're standing. Go ahead and help me annotate. What's important in that first sentence? Summer.
30 tomato plants and 24 cucumbers.
Okay. What's important in the next question or next sentence? What's important in the next sentence, Seth? Y'all gotta speak up. So he only wants one type of plant in each row. So those of you who told me that there are 6 rows, you are wrong. You are 100% wrong. Because that's not, what we just highlighted right there tells me that it's more than just 6. Okay? You've got to be careful. And this is how we miss really easy questions. on EOGs and benchmarks and quizzes and tests because we're not answering questions. We're just trying to find the basics. All right, what's important in the next one? Or the second half of that one. Ian,
How many plants do you put in
no. Second half of that second sentence. Oakley.
the same number of plants?
So the same number of plants in each row. Then it wants to know how many plants should be put in each row and how many rows of each. So we do have to find our GCF. Raise your hand to tell me what are the factors of 30. Kaden.
1 times 30.
Okay.
2 times 15.
Okay.
3 times 10.
Okay.
And then 5 times 6.
All right. Excuse me. What are my factors for 24? Peyton.
1 times 24.
Okay.
2 times 12.
Okay.
3 times 8. And 4 times 6.
All right. So obviously, 6 is going to be important, but 6 is not my answer. Why? Why is 6 not my answer? Or what part of the question does 6 answer? Let's start with that. Emma.
6 represents how many plants are going to go in each row.
So 6 plants in each row. So that's the first thing. The second thing is this number that goes with 6. That's the number of what? So the 5 and the 4 are the numbers of what? Sabrina. The what?
The number of plants.
Guys, you start like this and you finish like this. You might have the right answer. I just can't hear what you're saying.
The number of plants in each row.
Well, we already know that. 6 plants in each row, right? It already told us that. We already know how many plants, right? So we've answered part of this question. What's the other part that we have to answer? Jacob?
How many rows of plants are
How many rows of the plants? So the 5, what does the 30 go with? 30 what? Your 30 goes with what? What did you annotate up here? Again, I'm not asking you to produce something new. I'm just asking you to reread what you highlighted. So what does the 30 go with?
Oh.
Sabrina? Tomatoes. So you have 5 rows of tomatoes. So then what does the 4 represent? Sophia?
I was just stretching.
Okay, well, you should still be able to answer this. What does the 4 go with?
The 4 goes with the tomatoes.
No. It does not go with the tomatoes. Liam, the cucumbers. So you have 4 rows of cucumbers. All right. LCM. So it's going to require you to find the largest number that it starts with. It's going to ask you to extend a pattern or reoccurring events. So it'll have something to do with this person has this and this sport on these days. When will the next day be that they have the same sport? You're finding when the next thing will happen. And then you're trying to find the smallest possible amount. So you're going to see words like smallest, least, minimum, those kinds of words. So it says Robert works in the community garden every 2 days and Sally works in the community garden every 5 days. If they both worked in the garden today, how many days will it be before they see each other at the garden again? If today is July 3rd, what will be the date of their next meeting? You are finding LCM, ladies and gentlemen. Do not let me see you looking and solving for GCF. Stand up when you're done. All right, let's go ahead and go over this. So you're finding the LCM and you're using the numbers 2 and 5. Why? Why are we using the numbers 2 and 5? Ethan?
Because that's what the text provided.
Okay, so that's what it provides. So this question is asking you two things. First thing you have to do is find what? What's the first thing you have to do? Summer.
Find your LCM.
Okay. All right, so that part, pretty straightforward. So how many days will it be before they see each other again? Okay. Ian, so you have 10 days. So that's the answer for part of this question. The second part says if today is July 3rd, what will be the date of their next meeting? Well, how do you figure that out? What do you have to do? Kaden.
Add 10 days to the day it is, because you met them today.
Say that again, I'm sorry.
Just add 10 days.
That's what I
to
thought
the
you
day
said.
it is, 'cause you met them today.
Okay, so then they're going to meet again on July 13th. All right. Please make sure that you have that information. Now, you're simply going to fold this in half because there is a blank section on the bottom, and you're gluing that into your notebook. Slide over to the right side and title it GCF LCM Homework. And get out the piece of paper that I just passed out. All right, as you notice, these are all what? Word problems. So, what do you have to do? You're annotating all of the problems, whether you are solving them or not. You have 17 problems on this page. 16, and you're annotating all 16 of them. That does not mean you're solving all 16 of them. You must, in order to get credit for your homework, when I look at this paper tomorrow, if I don't see every one of these annotated, I don't care if you did the work or not. 16 problems need to be what? Annotated. You're picking 10 of them. You have 10 problems to do tonight. I don't care which 10 you pick. You must do your work in your notebook. Okay? So pick 10. Work in notebook. I don't know how else to make this. Yes.
Are we gonna like fold it up because the top so we can flip it up and go under it? Or do you just not let us do this?
Don't glue it in yet so that you can move it around, do whatever you need to do with it. I would not glue it in unless you are like, I'm gonna lose it. Okay? So you have a page in your notebook. If you need more than one page, use more than one page. But you're annotating all of the problems. So if you don't get credit tomorrow, it is because why? You did not annotate. So raise your hand and tell me, do you have to annotate all of these problems?
Yes.
You are picking 10, which means you're not doing all of them. You're getting to pick whichever 10 you want. And then the last thing, where are you doing your work? In your notebook. Can you write your answers on this page?
Yes.
Yes, and some of these you might not have to do work. Like some of them it might just be answering a question. Some of them you might have to do work and circle an answer. Just, that's it.